Okay, so this next example looks at the technique of using completing the square. I'll review completing the square in a moment, but first notice the issue with this integral. All right, if we try to let u be the bottom, then we have no derivative at the top. All right, we have no way to handle the derivative at the top. There's just nothing up there. All right, so we are coming up way short. Okay. So that's a bit of a problem for us, right? When we have nothing up top. So what we're going to do is take this denominator here and actually turn it into something squared plus or minus some other number. Okay? And then we can let u be the inside of that square part. Now, to complete the square, our first step is to make sure that the x squared has nothing in front of it. If it does, we'd have to do some factoring. Okay, so that's not an issue here. So the way completing the square works is if you have something like this, x squared plus twice a number times x plus that number squared, that thing will factor as x plus d quantity squared. So in this problem, I'm going to take my x terms here, bring them over. X squared plus 4x. And I want to figure out what do I need to have next to that? What number do I need to have next to that so that when I add it on, I can actually factor it? So we basically look at this and say, okay, we have this part of the problem. We just need to figure out what the d squared part needs to be. Well, notice that d is just always going to be half of whatever the x term is. So d is always just half of that number. In this case, 2. And so d squared will be 4. So we would need to have x squared plus 4x plus 4. Then we could factor that as x plus d, x plus 2 in this case, quantity squared. Okay, so that's the key idea. Now, when we come to this problem and we do that, we also have to keep something in mind, right? And that is we can't change our problem. Right? It has to still be the same as it originally was, just changing the way it looks. So with the x squared plus 4x, we need plus 4. So I add an extra 4 in there. And I still have the plus 8 there. So what I've done here is I've now added in a plus 4. So what I do is in that same line, I also subtract 4. So that essentially what I've done is I've added 0 to the equation. And this is a more advanced algebraic technique, this idea of adding 0. So we've added 0 to the equation. And now we've managed here to complete the square. Okay, because now this first piece, x squared plus 4x plus 4, can now be factored as x plus 2 quantity squared. And then the other piece, positive 8 minus 4, we can just simplify that. And so the key is, though, that we make sure that if we add something inside here, that we also subtract it. So we haven't changed anything. This is very much like our multiplying by 1 stuff that we do very often. Okay. But here we're adding 0. And so now we can rewrite this as dx over x plus 2 quantity squared, and then 8 minus 4 would be plus 4. And now this thing has been transformed so that it's in a format that we're actually going to be able to work with. But we're still not quite there. Right now, all we can do with this situation is realize that this x squared plus a number, this quantity squared plus a number, looks an awful lot like this tangent problem right here. Right? This tangent problem right here. So what we have to do right now is we have to reshape the way this looks so that it fits this format. That means I need to have it be +1. I need to have it be +1. So the first thing I need to do so that I can get it to be +1 is factor out of 4. Now later on in this chapter we are going to see another technique that's going to make this situation a lot easier. But for now we have to go with this longer process. So the first thing I do is factor 4 out of both of those. So, of course, when I factor a 4 from the x plus 2 quantity squared, I'll have to be dividing by it, and that'll make that +1. Now that 4 is just a constant, so it can be pulled outside the integral. And now I'm going to take that x plus 2 quantity squared over 4 and rewrite that as x plus 2 over 2 quantity squared. I guess I don't need this opening parenthesis there. And +1. So that now it's in the right format for my du step. Right? For my u step. So now I can let u replace that. Right? Let u replace that. So that I have a u squared plus 1, which I can then turn into a tangent. So we do that. Let u be x plus 2 over 2, the whole thing. Then du would be the derivative of that, which would just be 1/2 dx. So that means that to carry this integration through, I need a 1/2 to be by the dx. Okay, that's a number, so I can handle that. And then u is going to be the x plus 2 over 2 part. Okay, so working that out, that means I'm going to need to put a 1/2 with the dx. So the way I think of it is, well, since I'm putting a 1/2, I have to divide by it on the outside. So dividing by 1/2 is the same as multiplying by 2. So 1/4 times 2, integral of 1/2 dx over the quantity x plus 2 over 2, quantity squared, plus 1. And now we can let the substitution go through. So simplifying on the outside, it'll be a 1/2. This will be du over u squared plus 1, which is the inverse tangent function of u plus a constant. And then finally we finish it off by substituting in for u. And so we get the result 1/2 inverse tangent of x plus 2 over 2. Plus a constant. Okay. So by doing that, we're able to work the problem out. We're able to get our integral. Again, later on in this chapter, when we get to this point, we will have a better way to approach this. Okay, it's called a trig substitution. We'll use a particular trig substitution, which will allow us to transform this and save a good bit of this work here that we have to do. Okay, it'll save on the work we have to do here. So that's coming up a little later. But for now, we just have to make it match the u squared plus 1 format. That's why I had to do the factoring, do the rewriting of that x plus 2 squared over 4 part, okay, so that we can use the inverse tangent. Okay. Later in the chapter, we're going to have a slightly different way of handling this, which will definitely speed this process up some. Okay, but the main idea here, was this completing the square, to get it into a format where we actually can integrate it. Okay, and then we're following up here with the inverse tangent. Okay.